All right, in today's lesson, we're going to talk about graphing radical functions. So the two functions that we're going to be talking about graphing is a square root and a cube root. So up at the top, we have the parent functions, are the most basic type of square root and cube roots you can have. So the first one we have is a square root. And a basic square root will start in the middle at 0, 0. So we have a dot there, and then it goes up and off to the right. Then if you go off to the side, we have a cube root, because you notice the little index number is a 3. A cube root doesn't necessarily have a starting point. This one, you'll notice, has an arrow on both ends. Instead, this one has what I want to call more like a center point. It has like a center. So if it's a positive cube root, then on the left side, it starts down at the negatives. So then it starts to curve up to 0, 0. And then it will curve and go up and out through to the positive side. But a cube root will go on forever and ever on both the left and the right, whereas you notice a square root will have a starting point and then it will only go forever and ever in one direction instead of both directions. We do have some review topics that we haven't talked about probably since first semester that we're going to go back and hit on. The first one is domain. If we ask for the domain, remember domain is X numbers. And when you are writing your answer on domain, you always want to go with the smallest to the largest. So that means you want to start on the left side and end on the right side. The range is your Y numbers. And small to large means you want to start at the bottom and end at the top. And then the notations that we're going to use for domain and range is either going to be parentheses and or brackets. Parentheses will be used if we have open circles or if we're going to go for infinities or arrows. And a bracket will be used if we're talking about closed circles. And then the next review topic we have is transformations. Okay, transformations. We have f of x, or you can have g of x, h of x, or the letter y, equals, and then if you have a negative out in front, okay, a negative out in front is our first little bullet point here, and that means that you're going to have a reflection over the x-axis. Then we have an a next to the negative. So if you have a coefficient in front of your radical, then if your a is larger than 1, that will be a vertical stretch. If your a is less than 1, so if it's a fraction or a decimal, then that's going to be a vertical shrink. Just remember, when you're doing the vertical stretch or shrink, do not include the negative sign there, because remember, the negative means it's a reflection. So when you're talking about A, you're only talking about the letter A. Don't include the sign for the A, so don't include that negative. Under the root, we have x minus h, or it could be x plus h. Anything inside the root is going to be your left or right movement, and your left or right movement is opposite of what it looks. So if you have x minus h, then that means you're really going to go to the right. If you have x plus h, that really means you're going to the left. And then at the very end, we have the plus k, and you notice the plus k is not under the root, it's outside of the radical. That is your up or down movement. Up or down is exactly how it looks. So if it's a minus k, then you would go down. If it's a plus k, you will go up. Okay, so then on our examples here, let's actually skip down and do example number 2 first, and then go back to example number 1. Because example number 2 is asking for the transformations that you list out that we were just talking about. So let's go down and look at those first. So on the first one, on A, we have the 1/2 out in front. So the 1/2 is going to be in the A spot. Okay, so I'm just going to write a little A underneath of that. And the 1/2, that is going to be less than 1. So if it's less than 1, that means you would write a vertical shrink. So vertical shrink by 1/2. The next thing I notice is the part inside the square root, which is x plus 3. So that looks like my x plus h. And the part inside is your left or right movement. And remember, left or right movement is backwards. So x plus 3, you're really going to say is going to go to the left 3. And then at the end, we have this plus 5. So that's going to be in the plus k spot. And k is your up or down. And up or down is exactly how it looks. So you would say up 5. So those would be the 3 transformations that we would have for the first one. So now let's go over to the next one. For this one, I notice that I have a negative in front of the cube root. If you have a negative out in front, then that is going to be a reflection on the x-axis. Then I have this x minus 1 that's on the inside. And remember, if it's inside the root, inside the radical, that's your left or right movement. And that is backwards. So for this one, you would want to say right, oops, sorry about the paper moving there. So right 1. And then the minus 7, you'll notice, is outside at the end, and that's your k. Your k is your up or down, and up or down is exactly how it looks. So you would say down 7. Now, transformations are kind of important because that's going to help you know when you're typing things into your graphing calculator whether you've kind of typed it in correctly or not, because the left or right, up or down should kind of give you either if it's a square root, the starting point, or if it's a cube root, it might end up giving you the middle or the center of it. Okay, so that's why we're having you talk about transformations. So now if we go back up to example number 1, we have several things that we're going to do. So I give you h of x equals the square root of x, and then we have a minus 6 off to the side. And then we have several things down here we're going to do. The first thing I'm going to do is I'm going to jump down to the transformation parts. So if I look at the transformation, I do not see a negative in front, so no reflection. And I do not see a coefficient in front, so no stretch or shrink. Inside, it just has an x. It doesn't say x plus or minus a number. Do you notice that the minus 6 is outside, so there's no right or left? So on this one, all I see is the minus 6 at the end, so I'm going to say this one is just down 6. Which this down 6, just in my head, should tell me the starting point. So I'm just going to put ST for starting, and then I'll put PT for point. So if I'm going down 6, that means I'm going to stay in the middle, and then I'm going to go down 6. So that should be my starting point, which I can verify on the graphing calculator here in a little bit. And then the rest of this information I'm going to get from the graphing calculator. So now I'm going to switch my screen over to my graphing calculator. Remember to graph something, once you turn the calculator on, you want to go to the y equals key. So I'm going to go up to the top to the y equals. If you have anything typed in there, just hit clear to get rid of it. Your square root key. Okay, your normal square root key is above your x squared key here in blue. So you're going to hit second and then the square root key so that your x squared comes and pops up. Remember, x is located right next to the green alpha. Now, the -6, we don't want it to be under the square root. So you need to make sure you hit your side arrow key so that you're going out from underneath the root, and then you can hit the subtraction key and then 6. And you notice that the square root does not go over the -6. It only stays over the x, which is what we wanted. Okay, so now the first thing we want to answer is h of 4. So to help me get that, what I'm going to do is I'm going to go to the table feature. Remember, table is above graph. So hit second graph. And then on my table, remember, you can scroll up and down. And you want to go here to the x column where it has 4. And across from 4 is the y value, which is -4. So then if I go back here to my other screen, then we should be able to write down my answer here, which was -4. So that's going to give me, if I think of this as a point, that's going to give me 4, -4. And now we're going to go back to the graphing calculator. And the next one is h of 9. So I'm going to keep scrolling down, and I'm going to get to 9. And that one is -3. So then that ordered pair would be 9, -3. Okay, so I'm going to plot these points onto my graph paper. So 0, -6. So stay in the middle, go down 6. 4, -4. So you're going to go right 4, down 4. 9, -3. So you're going to go right 9 and down 3. And then I'm going to go ahead and draw my picture. Now let's make sure that this matches what the graphing calculator has. So now if I go back here and I hit graph, oh, my screen has been changed. Remember, if your screen for your graph has been changed, go to zoom and then choose 6. And now when you choose zoom 6, you'll notice that this picture looks like my picture. Yay, that we plotted. So we know that ours is correct. So now let's go over here and list our domain and range. So for the domain, if I start on the left and I work my way in, the very first time I'm going to hit my picture would be right here. And this would have the x value of 0, and that's going to be a closed circle, so you should have a bracket. And then on the right side, if I work my way in on the right side, you'll notice that you're going to hit an arrow, and an arrow is infinity. And infinities always have a parentheses. Okay, range. Range, we're going to start at the bottom. So if I start at the bottom and I work my way up, the very first time I'm going to hit my picture would be at this dot, and that has the Y value of -6. That is a closed dot, so bracket -6. If I start at the top and I work my way down, then I will hit an arrow. Now this, don't let this confuse you. The arrow is still going up forever and ever. So even though it's down on the negative portion of the graph, this is still going up forever and ever. So you're going to positive infinity. And then you have a parentheses. Now, what do you notice about your domain and range here versus your starting point? Oh, look, I noticed that my starting point, the X number is 0, and that is the same starting of the domain. Oh, look, in my starting point, the Y value is -6, and that is the same starting of the range number. Woohoo! So that's just a little conclusion that you can make there. Okay, so for the last one, for this one, the only transformation we have is the one inside the root. So inside the cube root, x plus 4, that's right or left, and that's going to be backwards. So you're going to say left 4. Okay, and this transformation, it's not going to give you a starting point because remember a cube root is the one that goes forever and ever on both sides. So this is going to give you the center point. So our center point is going to be -4, 0. Okay, so now let's go type this into the calculator. So I'm going to go back to y equals clear. To get a cube root, you need to go to the math key. And when you go to the math key, you will notice that number 4 is the cube root. So I'm going to go down to number 4, hit enter, and then x plus 4. Now the plus 4 is under the root this time, so make sure you don't side arrow out. Make sure it stays under the root. Okay, we're going to go to the table, and this time I'm looking at -5. And -5 is -1. And then the other one I'm looking for is 4, which at 4 is 2. So then I'm going to go put both of these down. So -5 was -1, and 4 was 2. So these are going to give me some other points. So -5, -1, and 4, 2. So now I'm going to go plot these. So -4, 0. And then -5, -1. And 4, 2. Okay, so now remember we talked about this one. Okay, it's going to start to curve to the center, and then when it goes to the center, it's going to curve and go out in the other direction. Okay. And then domain and range, you will notice that both domain and range, it goes forever and ever. If you're looking at the left and the right, so this one you would say -infinity to +infinity, parentheses around both of those. And then bottom and top, if you do that, it's still going to hit arrows. So domain and range is also all real numbers, so -infinity to +infinity. So a cube root, the domain and range will both be everything. So it should always be -infinity to +infinity. Okay, and then you're done. That's it.